Tomorrow's test covers 10.1 to 10.4. There are 16 questions on the test. And the reason why we're going to split this up is, as you can see from this outline, it's a lot of information. So this first slide is just from 10.1. So be able to identify any vocabulary we talked about in a question. A lot of the vocabulary identification will be a multiple choice question, just like on the quiz. So be able to define all of these words. Also be able to apply all of the theorems that we covered. So we covered 2 theorems in 10.1. Then in 10.2, we learned additional vocabulary terms. And then we learned a postulate and 3 theorems. Then in 10.3, we learned the 4 theorems, and then we did applications of those. And then in 10.4, we covered some new vocabulary terms and then also covered 4 new theorems. So this outline is on Canvas. It is in the module. And again, you can fill it in to use to study. So what we're going to do now is we're going to go through the homework that was due this morning. I will work out any questions you want to see worked out. I won't work out all of them if there aren't questions on it. Now, this review, and some of them may be even questions, but these 4 pages that I gave you to do for homework last night reflect the content that is on the test. So if you could do this homework with no problem, then tomorrow's test should be nice and easy. However, some of the content may be even questions. So my advice to you is go back and work the evens tonight as an additional way to study. So this was on the quiz, number 11. However, when it was on the quiz, it was like number 10, where you didn't have to factor. However, tomorrow you will be factoring. So for example, number 11 is a good one to practice. So we learned a theorem that stated when 2 tangents meet at the same common endpoint, that these 2 tangents would be congruent. So I'm going to be setting 4x squared minus 18x minus 10 equal to x squared plus x plus 4. I need to set my equation equal to 0. So what I need to do is get my like terms together. So I need to subtract x squared from both sides. It cancels from the right side. And then 4x squared minus 1x squared is 3x squared. I still have the negative 18x minus 10, and then the x plus 4 on this side. I still need to get like terms together. So now let me subtract x. So now the 3x squared is here. I now end up with negative 19x. I still have the negative 10 equals the x plus 4. Oh, the x plus 4 is gone. The x is gone. So now it's just equals x. So now I have equals 4. And now I just need to move the last piece, move the 4. And now I have 3x squared minus 19x minus 14 equals 0. Now, I have a trinomial that I need to factor. So you can either guess and test, but I'm going to do grouping. So I'm going to multiply the beginning and the end. So I am looking for 3 times 3x squared times negative 14 gives me negative 42x squared. So I'm looking for the factors of that will sum to give me the negative 19x. So if I start my list, my signs have to be different, and my bigger factor is going to be negative. So when I go to do this one, this gives me negative 41x. It doesn't work. However, if I do positive 2 and negative 21, this gives me the middle term that I need. So these are my factors. I rewrite the first term, the 3x squared. I'm replacing the middle, the negative 19x, and this shouldn't be a square here, this should just be an x. So then I'm going to replace that negative 19 with the two factors I just found. So the negative 21x and the 2x. It doesn't matter the order that you place them. You will get the same answer either way. So now I'll make my groups, and then I'll factor out the GCF. So the greatest common factor of my blue group will be 3x. After I divide, I'm left with x minus 7. GCF of purple is positive 2. And then after I divide, notice I have the same common factor here now. So that becomes one of my binomials. And then the two GCFs that I factored out become my second binomial. Now, it doesn't say to factor, it says to find x. So now I have to set x minus 7 equal to 0, and then the 3x plus 2 equal to 0. I'm going to add 7, subtract 2 on this one, and then divide by 3. So my two answers for this problem are going to be x equals 7 and x equals negative 2/3. So that was number 11 on the first page. All right, number 9. This one, it's telling us that point B is a point of tangency, and it wants us to find the length of the radius. So because point B is the point of tangency, I learned a theorem that stated when a tangent and a radius intersect, they form perpendicular lines. So this tells me my right angle is located at point B, that point of tangency. So what I need to do here is Pythagorean theorem. So the two legs, this could be A, this could be B, and then this is my hypotenuse, and it's formed by adding the r plus the 3.6. So because it's a right triangle, I can use a squared plus b squared equals c squared to find the length of the radius. So my a value, I said, was going to be the 4.8. I have to square it. The b is my r. And then my hypotenuse is r plus 3.6. Now, when I square this r plus 3.6, I have to FOIL this. So I'm going to go ahead and square the 4.8. So 4.8 squared gives me 23.04. The r squared I'm going to leave. Now, when I square this, it's really doing r plus 3, or r plus 3.6 times r plus 3.6. I'm going to do my FOIL. So r times r is r squared. R times 3.6 is 3.6r. The inside, same thing. And then 3.6 times 3.6 is going to give me 12.96. So now I need to add my like terms here, and 3.6 plus 3.6 is 7.2r. Let me just rewrite everything. Rewrite this side. So now I need to try to start getting my like terms together. So if I try to move my r squareds together, notice it cancels on both sides. So now I'm left with 23.04 is equal to 7.2r plus 12.96. So now I'm going to subtract the 12.96 from both sides. And once I do 23.04 minus 12.96, go ahead and move it over here, I get 10.08 equals 7.2r. And then now I need to divide both sides by 7.2. And r is equal to 1.4. Okay, so for number 7, it wants us to tell whether the given arcs are congruent and then explain why or why not. So for number 7, I can go ahead and fill in what I know. I need to figure out, so AB is, this one is, let me do this one in purple. So AB's arc is here and CD's arc is over here. Well, I can already figure out AB's arc because I have a central angle measure. It's 42 degrees. Remember, when it's a central angle, the arc measure is the same. Now, I have all of the other angle measures, so I can find this angle measure right here, which will also be the same as the arc measure. So I'm going to add 180, 96, and 42. And then once I get that sum, I'm going to subtract it from 360. So I get 318. And now 360 minus 318. And I get 42. So this angle is 42. And so is its arc. So the theorem that's stated for congruent arcs is within the same circle, if they have congruent central angles, then the arcs are congruent. So this would be yes, because they have congruent central angles. Now, if they're two different circles, then you would have to make sure that they are congruent circles. In other words, they would need to have the same radii length. So if they're two separate circles, so let's say I go ahead and draw two different circles. And let's say this has 40 degrees and this has 40 degrees, but I give you a radius length of 2 for this one and a radius length for 3. So this could be circle A, circle B, and let's say this is CD and XY. And let's say it asks you, is CD congruent to XY? When they're two different circles, they must be congruent circles. So even though these two arcs have the same measure, they are not congruent arcs because they are not congruent circles. So when they're two different circles, they need to have the same radius length. But when it's within the same circle, as long as they have congruent central angles, then the arc measures are congruent. So these could have both 40 and 40, but because the circles are not congruent, those arcs are not congruent. Okay, so this is using our equidistant chords theorem for number 9. And because I can see that these two chords, EF and GH, both measure 15, I can tell that these chords are congruent because they both equal 15. So then that would tell me, because I have congruent chords, these chords, because I've got the right angle, these are two distances and they are congruent. They're equidistant from the center because the chords are congruent. So this would be congruent to this. So I need to set 4x plus 1 equal to x plus 8. I need to find the value of x, and then I need to plug it back in. So I'm going to subtract x. I get 3x plus 1 equals 8. Subtract 1. 3x equals 7. Divide by 3. And x equals 7/3, or 2 1/3. Now, it did not ask us to find the value of x. It asked us to find the length of the radius. And in the picture, they have not drawn a radius for me. So I'm going to draw one in. Now, you can draw your radii wherever you want. You could either connect it to the CE, you could do CF, you could do CH. These are all radii. I only need to do one of them. So, for example, let's say I wanted to do the radius for CF. That is now creating with this side, this part of the 15, and then this segment that I just found the value of x for, I've created a little right triangle here. So let me go ahead and pull that out. So for my right triangle, this is FC, the right angle, and I know that this point that's right here, where this equidistant segment hit, is a perpendicular bisector. So it's gonna split the 15 into 2 equal pieces. So this little piece here, which is this, is 7.5. Now, in order to find this length, I just found the value of x. This length is the 4x plus 1. So I need to plug in my value of x to get that length. And then to find the radius length, I'm going to be doing Pythagorean theorem. So once I take the 4x plus 1 and plug in, and I'm going to plug it in as the 7 over 3, I get 28 over 3. I'm going to change my whole number 1 into 3 over 3, which gives me 31 over 3, which if I divide this, it gives me 10.3 repeating. So now, so what I'm going to use here, I'm actually going to use 10.33. So this side is going to be 10.33, and I'm looking for the R. So remember, the two sides that form the right angle, this is your A and your B. Doesn't matter which one is A or B. And then the radius we're looking for, that's going to be the C. And my formula, A squared plus B squared equals C squared. So I'm going to plug it in. 10.33 squared plus 7.5 squared equals C squared, which in this case is my radius. Let me go ahead and just put that in as an R. So this is R squared, and this is what we're solving for. So I'm going to square 10.33, and I get, I'm going to round it to the tenths place, because what I get is this. So I'm just going to make it 106.7, and then I'm going to square the 7.5. I get 56.25. And it equals the R squared. So I'm going to add these two. And I get 162.95 equals R squared. I don't want R squared, I want R. So I'm going to square root it. And then I'm going to round to the tenths place. So I get 12.765. It's going to keep going. But I'm going to round to the tenths place. So 12.8. is the length of my radius. Again, tomorrow it's going to be an integer. You're not going to have to round any decimals. So let me fill in what was given to me. So I was given that arc LM right here is 84. I'm also given that arc KN is going to be 116. Now, I can go ahead and not necessarily have to answer them in order. I could do it out of order if necessary. So let me find JKL. Let's see if I can do it without filling in the whole picture. So JKL is right here. Notice this is an inscribed triangle, so that tells me that JKL is 90 degrees. Because the side of that angle is the diameter. And then if I want KMN, KMN is right here. Notice the endpoints, or its intercepted arc, is the 116. So remember, when it's an inscribed angle, you take that intercepted arc, divide it by 2, and 116 divided by 2 is 58. So we learned a theorem that told us about the measure of the inscribed angle. It's always the angle measure that when it's inscribed sitting on the side is half of the arc measure.
So since it's facing 116, you divide by 2.
Yep. All right, next it wants us to find KLN. Trace over that one. This one also has the same, KLN has the same intercepted arc as the blue one. So it's the same intercepted arc. So it's 116 divided by 2. And this one is also 58 degrees. So we learned a theorem that when they have the same intercepted arc, those angles are congruent. Next, it wants me to find arc measure MJ. And MJ is, arc MJ is right here. So now I need to figure out what I've got here. Right here, let me highlight. This is a semicircle because JL is the diameter. So this arc that's right here is a semicircle arc. And if I already know this piece is 84, to find the other purple piece, I just have to do 180 minus 84, and I get 96. So that's the answer for MJ. So MJ, this piece is 96. For number 2, MKL is here. And notice its intercepted arc is the 84. So if I do 84 divide by 2, number 2 gives me 42 degrees. And then JKM is right here. This angle in pink now. And its intercepted arc is the 96. So here I'm going to do 96 divided by 2, and that gives me 48 for JKM. And then angle LNM, so let me highlight that one. So LNM is this one here, this gold one. So again, it's got the same intercepted arc here of 84. So I'm going to do 84 divided by 2, and it's 42 as well. And then lastly, LKJ. So LKJ is this angle here, and its intercepted arc is composed of adding the 96 plus the 84, and then dividing by 2. So 96 plus 84, and then divide that by 2. So let's see, 96 plus 84 gives me 180, and then divide by 2. Oh, it was already the right angle. So, so its intercepted arc is 180. So I don't have to divide by 2. It was the arc, not the angle. All right, so that was finding all the different arc measures. Again, on the test tomorrow, it's not this complicated where you have to find a whole bunch of pieces.
That's not good. Can we do it a different way?
Yes, so I'm gonna show you the other way you could have done it. So, and I'm gonna do that for X. The other way that you could do it is you could have found AB's missing arc by adding 84, 80, and 152. Once you add these 3 arcs, you get 316. Then you can subtract that from 360 and get 44. Then the other way to do it is 4x, its intercepted arc is the 44 and the 84 added together. I get 128. I know this angle is half of that. So if I divide it by 2, I'm just going to get 64, and that's what I set 4x equal to. So other ways you can do these, and you get 16.